Welcome back to the Geometric View, episode 58, season 5. Today we get into Wigner crystals, which are solid electron crystals, nuclear geometry, spintronic computing, charge and charge separation, emergence, self-organization, atomic structure, and everything being based on layers and layers, like a Russian geometric nested doll.
I'm Putty James, your host.
Let's get into it.
Let's get into the circuit.
We greatly appreciate your support. The best way to donate to us is on PayPal. Just send money directly to goldenscaling@gmail.com. Thank you very much.
All right. Welcome everybody to the Geometric View, episode 58, season 5. Today we're going to get into Wigner crystals, solid electron crystals, nuclear geometry, spintronic computing, charge and charge separation. Basically, we're going to be getting into atomic structure, self-organization, emergence. These Wigner crystals are electrons that have become crystallized. So imagine an electron crystal. There's a structure, a geometric structure, of course, to this structure. A geometric structure, of course, to this, as there is with almost all emergent properties of the universe, all the fundamental forces, everything that life is, how life carries itself, everything is geometric. So we're finding this on all scales. And what is this geometry? How is it all interconnected? And that's what the geometric view is here. We get into how everything is, actually we get into interdisciplinary geometry, which covers all disciplines, and how the geometry relates to not only astrophysics, astrotheology, nuclear physics, atomic structure, also plasma. It gets into everything in the universe, the inner body, the microbiome, interscalar, planetary, scalar. It gets into multi-scales. All of this is all scalar physics, scalar geometry, and how these patterns reoccur. It's all through mimicry and how they reoccur. So Wigner crystals are really extremely interesting. I got my attention brought to them by a drawing that I did, and then I seen images that were being published in Nature magazine and Nature Journal and things like this. And so I was like, oh wow, I know exactly what that pattern is. This pattern is the pattern that I've already drawn myself, and now I'm seeing it in physics and in math, of course, as time and time again I find these discoveries, and then I'll find whole entire phylums of scientific inquiry, or entire like Spintronics, for example, which is what we're going to get into today. Spintronics as well. Let me hug this mic a little bit more here. All right. So a way to put this is multiple layers singing the same song and organizing it in subsequent shells as metastructure through reoccurring phase transition of charge and charge separation, reoccurring these resonant sympathetic geometries that are occurring on smaller scales and larger scales. So yeah, I think we get the idea, and it's all fractal. All of the whole process is through the emergence and self-organization. It's all we're finding to be fractal. So let me get into, excuse me, sharing my screen. We might have people popping in throughout the day through this conversation, because it is a group meetup that I'm posting on here. So if we do have interruptions from people, not interruptions, we'll have welcome visitors. So let me share my screen here. All right, and I think we're going to get right into the presentation. And as with most of my, as with most of the podcasts here, I come out with new maps, new cartographs of the universe, or of the Dougherty set, new perspectives and new ways of looking at it as it integrates with other theories. So we'll get into the presentation here. I have a thing right here, so start slideshow. I don't want to see this. There we go. All right. Wigner crystals, nuclear geometry, spintronic computing, Toroidal roots, and electrotropism. Let me say that again. Nuclear geometry, spintronic computing, Toroidal roots, and electrotropism. There's so much more we get into, but that's what I narrowed down the subtitle to. Eugene Wigner. What did Eugene Wigner discover? In 1933, Eugene Wigner discovered that the force binding the nucleons together is very weak when the distance between them is great, but very strong when the nucleons are close to one another, as in the atomic nucleus. So we're going to get into wells, perturbations, the voids, how the crest and the trough of the wave, the field building the form, open shapes and closed shapes, and this is all very important when you get into the center of the nucleons and the binding, the field creating the force and the forms that we're seeing as quarks and other geometries. So in this episode, we're getting into nuclear physics, of course, as the geometric view is interdisciplinary geometry. What is an electron crystal? A Wigner crystal is the solid crystalline phase of electrons, first predicted by Eugene Wigner in 1934. A gas of electrons moving in 2D or 3D in a uniform inert neutralizing background will crystallize in a form and form a lattice if the electron density is less than the critical value. So we'll keep going, and as these lattices form, we'll see. Oh, sorry. Yep, that's the next one. A solid crystalline phase of electrons. So it builds up this lattice we're seeing here. So this is because the potential energy dominates the kinetic energy at low densities. So the detailed spatial arrangement of the electrons becomes important. To minimize the potential energy, the electrons form a BCC, body-centered cubic lattice in 3D, a triangular lattice in 2D, and an evenly spaced lattice in 1D. Most experimentally observed Wigner crystals exist due to the presence of an external confinement, i.e., external potential trap. As a consequence, derivations from the BCC or triangular lattice are observed. A crystalline state of the 2D electron gas can also be realized by applying a sufficiently strong magnetic field. However, it is still not clear whether it is the Wigner crystallization that has led to observations of insulating behavior in magnetotransport measurements on 2D electron systems, since other candidates are present, such as Anderson localization. Now, I'm going to get into quasi-periodic tiling and quasi-crystals because these are important in the Dougherty set and in birkeland currents and in the circuit as circuitry dynamics unfold uh, and are designed naturally. The cables, the cosmic power lines, the structure and substructure of those have similar structures. How we form structures ourselves, wires ourselves. I mean, they are. There's a term for it, but I can't remember right now. I'll remember it here in a minute. But quasi-periodic tilings. Quasi-periodic tilings are those tilings in which finite patterns appear regularly in the plane. This property is a generalization of periodicity. So the periodic chart, periodicity, atoms, atomic structure, periodic table of elements. It's periodic tiling and periodicity that we're looking at here when we're looking at the nucleons and nuclear physics here of the atom and the atomic structure. So quasi-crystals were first discovered in the 1980s by Dan Schneckman, but the interpretations preferred for them were not accepted by many in the scientific community, bar physicists, for some time. After all, they upset nearly 2 centuries of scientific understanding about the structure of matter. So, of course, it's showing that it's fractal, as many theoretical mathematicians and mathematicians have theorized about before. Buckminster Fuller, Walter Russell, quite a few to name a couple there. So Wigner crystals, more generally, a Wigner crystal phase can also refer to a crystal phase occurring in non-electronic systems at low density. In contrast, most crystals melt at the density as the density is lowered. Examples seen in the laboratory are charged colloids or charged plastic spheres. So what can Wigner crystals do? The Wigner crystal locks electrons into stable positrons only when 2 electron sheets assume a particular triangular geometry. So it works in the A3 lattice in the CC, cubic centered packing arrangement. Now I wanted to get into electrotropism and how these crystals are formed and why they are the shape that they are, and the rouleau triangular, rouleau solid type of shape that they are. And okay, anyway, I'll continue. Excuse me. Electrotropism is a kind of tropism which results in growth or migration of an organism, usually a cell, in response to an exogenous electric field. This is indicative of the mammalian and cross-phylum pentafractal growth patterns of living structures on this planet. So you can see here, these almost look like living creatures, but it's all describing seed growth and growth on different organisms, like single-celled organisms, mold, amoebas, different things like that. But it almost looks like bugs and living creatures. So we can think about here in the pertaining to the electric universe, the squatter man, and also sonotropism, which I talk about a lot here on this podcast, and is the sound pulling organisms up out of the ground, and sound reverberation being the cilia. Really, the cilia, like of the earth, would be the different plants and trees, and the sound pulls them up off of a larger field that's out here. So you have a positive and a negative, and you get charge and charge separation, and a result of charge and charge separation is trees. So you get phototropism and electrotropism, and eventually, as this cascading network branches out from every other point and every other atom, as they continue to do creature stacking, and what I call creature stacking, growing creatures off of creatures, which is how we got here, creatures off of creatures off of creatures, fractal stacking. So you look at the structure of these, and especially if you see it has this inner space here I'm talking about between three gates. The structure that you get in between three gates, which would actually be one gate, the three gates to the north here, for example, you get a pinch here, which is the head. You get the torso, the body. You get a pinch here, which is the arm. You get another pinch here, a peduncle. You get another pinch, which is the other arm. You get the chirality of opposites, which is what our hands are, and our bilateral symmetry. You also get radial symmetry, supersymmetry, and scale symmetry inside of this network here. This initially is the picture that I drew inside the Dougherty set. These images that this pattern we'll see throughout this episode, because this is the one that looks just like the patterns that they found of Wigner crystals. So you also get the bottom one here. You get the two legs. It can be, looked at in different directions, but here's the two legs, and then you get a pinch here for the private, or the crotch, the reproductive genitalia. So what we have here is what seems to be a pentafractal kind of structure, like our hand, pentadactyl, but it's actually 6. 1, 2, 3, 4, 5, 6. It looks like 5 point star, but it's 6 because the head and the genitalia are pinches along the fulcrum of the 90-degree fulcrum of the north-south magnetism, east-west magnetism. You get quad poles. There's quad poles, orthogonal type of magnetism here going on as these structures scale and as life builds off of these fractal cascading networks. There's an abiotic and a prebiotic geometries that organize life and forms into the shapes that they are going to grow into, and that's what we're talking about here, this prebiotic, abiotic, pre-life existing geometry that pulls life into the different ferns of the ligaments, which phalanges, and then you got a recurring phalanges of 10 toes, 10 fingers on top of this geometry. So this is a really efficient, important thing to understand about these wells here, these dampening wells, which we'll get into a little bit more, as perturbations and voids and nodes and crests and troughs. But this is all this part of the spherical cascading network that is all golden mean scaling. It is all phase conjugate. There's so many different systems that are phase conjugate growth and allow for the golden mean to propagate and organize through self-organization other systems, living systems like this. So that's the long and short about electrotropism and self-organizing systems in life. Let me hit the next slide. But that's just important. I wanted to add that in there because this is a lot of insight into these Wigner crystals and how they interact on a small and a larger scale. So why are Wigner crystals important? Forming a Wigner crystal in graphene enables a new platform that can be used to study a system of correlated electrons. Possible applications for this include quantum computing. Spintronics, also known as spin electronics, is the study of the intrinsic spin of the electron and its associated magnetic moment. in addition to its fundamental electronic charge in solid-state devices. So Spintronics is the application that we're using through computing. That's a type of computing. And we did a whole episode about that, and that's really interesting. I love that whole idea here with that, what Spintronics is. But as you can see here, this pinch, Z pinch, Z pinch, these pinches where the cones kiss noses, as Dan Winter says, phase conjugation, these locking points, are what the mesh is made of. And it's not just two-dimensional, but a three-dimensional, and we'll get more into how it opens up as well. There's moire patterns and angles here. We have, of course, I'm trying to show the correspondence between the Wigner crystals and moire patterns, hexagonal moire patterns with graphene and twisted bilayers of graphene, and getting that pattern of that quasi-crystal growth again, this substructure that keeps coming up as an emergent fractal growth iterative process in the construction of birkeland currents and currents in general, and circuitry, how circuitry cascades the network of life and living organisms through ultimately the Schumann cavity, the Schumann resonance. We are a result of that. We're living systems. We're in this geometry. We are living in this right now as we speak. We are the open windows of order inside the Feigenbaum constant that predicts open windows of order for life to persist, and for systems to have really rare, significant open windows of order that, the system closes back into chaos, collapses back into chaos quickly. So these geometries on fundamental scales, on larger scales, these are the incommensurable heterostructure or quasi-crystalline geometries. There's commensurate superlattices here. There's incommensurate and commensurate. And when you focus these graphene patterns on top of each other, you start to build more interface, more communication, interference, constructive and destructive interference that builds larger scale, probably the larger scale organism that we're inside of, the Laniakea structure, but more like the Akashic memory, the Akashic three-dimensional holography of fractal hologram geometry of the universe. So anyway, I digress, but for the progress, experimental realization. In practice, it is difficult to experimentally realize a Wigner crystal because quantum mechanical fluctuations overpower the Coulomb repulsion and quickly cause disorder, kind of like what I was trying to say here. Low electron density is needed. One notable example occurs in quantum dots with low electron densities or high magnetic fields where electrons will spontaneously localize in some situations, forming a so-called rotating Wigner molecule, a crystalline-like state adapted to the finite size of quantum dots. Another experimental realization of Wigner crystals occurred in single electron transistors with very low currents where a 1D Wigner crystal formed. A current due to each electron can be directly detected experimentally. So you got the nodes and you got the filaments in the nodes, and they're all being progressive and productively distributed using vortex technology. These Wigner crystals aren't only showing here the topology of electrons and rotating electrons, but they're showing another substructure of very tightly nestled vortexture, vortostructure, vortospheres. Wigner crystals and its spin properties. In 2018, a transverse magnetic focusing that combines charge and spin detection was used to directly probe a Wigner crystal and its spin properties in 1D quantum wires with tunable width. It provides direct evidence and a better understanding of the nature of zigzag Wigner crystallization by unveiling both the structural and the spin phase diagrams. This is awesome. Direct evidence for the formation of small Wigner crystals was reported in 2019. Since then, there's been so much more. I'm sorry, I hit my mouse. So we're seeing that there's a structure and then a substructure and then a substructure. Like there is this metastructure, metadata. There's a fractal structure of the fractal structure here. So here we go, and we're seeing that it's in 1D and 2D and 3D, and we'll get into the Dougherty set here in a minute. 1D Wigner crystals. Conductance maps around the domain wall showing the energy evolution of a 1D Wigner crystal. That's what we're looking at here. STM, spectroscopic maps, show that once the lower Hubbard band crosses the Fermi energy, the charges rearrange to minimize Coulomb energy, forming zigzag patterns expected for a 1D Wigner crystal. The zigzag charge patterns show characteristic noise structures signifying charge or spin fluctuations induced by the tunneling electrons, which is expected for this more fragile condensed state. The observation of a Wigner crystal at orders of magnitude higher temperatures enabled by the large Coulomb energy scales combined with the low density of electrons makes this a promising system for exploiting the charge and spin order in 1D Wigner crystals. So obviously we're having what looks to be a helical type of or toroidal type of connectivity to me. Wigner crystals domain wall, band bending across the domain wall here. More helical flow, more geometry of the Wigner crystals, more proof of the Wigner crystals' existence, or more evidence showing and supporting that. Patterns within absolute zero. So Wigner crystals form near absolute zero temperature, forms in near absolute zero temperature. Thus, it is a first principle geometry forming within the atomic nucleus. So we went through this image earlier, and this is what actually got me into Wigner crystals. I'm completely unbiased. Any direction that I go with this, if I find a pattern that looks like it, I'm going to start talking about it. So you can see that the collapse of the explosive vortice and information packet and all the information here inside of this field is contained inside these perturbations here within the network that are two opposing spiral vortices, as Russell says. Now these two opposing spiral vortices, there's the generative vortice, which is the thrust inward. Then there's the explosive death, degenerative, radiative energy that's vortex that's pushing outward. So you have this pinch and pull on everything. That's what allows the perturbations to exist. And frankly, this looks like butterflies. This looks like especially if you color it certain ways, butterflies and moths sit perfectly along this axis. And as they turn into their chrysalis, this looks like a chrysalis, and it looks like the egg and it looks like the worm. I mean, you see the metamorphic structure and the metamorphic forms and formations that are inherently inside of the Dougherty set here. And this geometry is just the consequence of it is first principle magnetohydrodynamic geometry. It's geometry that is coming from the sun, geometry that is mimicked here on Earth, geometry that is atomic. It is subatomic. It is all throughout the scales of the galaxy. It explains stellar formations and why stellar formations exist in certain geometrical patterns as well. So we get into a lot of that in different episodes. But yeah, mainly I just wanted to hone home at how important this structure. When I found it, I'm like, what the heck are these? And then I found out they're rouleau triangles, and they actually move. This entire thing is showing a system of moving rouleau triangles. Then I looked at I kept seeing Doctor Strange's symbol, and it looked so similar to this. Doctor Strange's symbol, from the Marvel comics or whatever. And his powers and everything else that he works with, and being able to work with moving through time, being, omnipresent, being able to go anywhere in time and space. So it's not exact. It's not exactly as Doctor Strange's logo, but what it does do is it rotates, and we'll see this later in the presentation. Probably going to go into a video of it, hopefully. Is this rolls like a ball when you design a rouleau, three-dimensional rouleau triangle. It rolls perfectly like a ball. You can use it as bearings. In fact, they do, and there's a bunch of rouleau solids that exist like this, and you can roll all of them just like a sphere. So it's really cool. So the dynamism here is not really completely disclosed, but when you see the newest Spider-Man, you see that Doctor Strange is moving this geometry, and the rouleau triangles are creating a larger three-dimensional structure, which is really cool and telling. But I'll continue here. Why is that like that? Oops. I don't know why this is like that too. What does a solid made of electrons look like? We'll have to just kind of wing this one. Crystals have fascinated people through the ages. Who hasn't admired the complex pattern of a snowflake at some point, or the perfectly symmetrical surfaces of a rock crystal? The music doesn't, something doesn't even stop if one knows that all of this is a result from a simple interplay of attraction and repulsion between atoms and electrons. A team of researchers led at this place in Zurich have now produced a very strange special crystal. Unlike normal crystals, it consists exclusively of electrons. In doing so, they have confirmed a theoretical prediction that was made almost 9 decades ago, and which also has been regarded as a kind of holy grail of condensed matter physics. Their results were recently published in the scientific journal Nature. This is it, a decades-old prediction. What got us excited about this problem is its simplicity, says Amoglio. Already in 1934, Eugene Wigner, one of the founders of the theory of symmetries in quantum mechanics, showed us electrons in a material could theoretically arrange themselves in regular crystal-like patterns because of their mutual electrical repulsion. The reasoning behind this is quite simple. If the energy of the electrical repulsion between the electrons is larger than their motional energy, they will arrange themselves in such a way that their total energy is as small as possible. These are the pictures that I saw in my geometry, and I was like, oh my gosh. I'm like, those are complete Wigner crystals. I was like, what? Crazy. This is completely exactly what I drew. So they're doing it on a three-dimensional scale. I'm doing it on a cascading network scale. Um, so for several decades, however, this prediction remained purely theoretical, as those Wigner crystals can only form under extreme conditions, such as low temperatures and a very small number of free electrons in the material. This is in part because electrons are many thousands of times lighter than atoms, which means that their motional energy in the regular arrangement is typically much larger than the electrostatic energy due to the interaction between the electrons. Oops. Electrons in a plane. To overcome those obstacles, Amuglio and his collaborators choose a wafer-thin layer of the semiconductor material, molybdenum diselenine, that is just one atom thick, and in which, therefore, electrons can only move in a plane. The researchers could vary the number of free electrons by applying a voltage of two transparent graphene electrodes between which the semiconductor is sandwiched. According to the theoretical considerations of electrical properties of molybdenum diselenine, should favor the formation of a Wigner crystal. And sorry, I just botched that name of that chemical. Provided that the whole apparatus is cooled down to a few degrees above the absolute zero of minus 273.15 degrees Celsius. However, just producing a Wigner crystal is not quite enough. The next problem was to demonstrate that we actually had Wigner crystals in our apparatus. Who is the lead? Oh, says Simolensky, who is the lead author of the publication and works as the postdoc in Amuglio's laboratory. The separation between the electrons was calculated to be around 20 nanometers, or roughly 30 times smaller than the wavelength of visible light, and hence impossible to resolve even with the best microscopes. Detection through excitons. Using a trick, the physicists managed to make the regular arrangement of the electrons visible despite that small separation of the crystal lattice. To do so, they used light of a particular frequency to excite so-called electrons in the semiconductor layer. Excitons are pairs of electrons and holes that result from the missing electron in an energy level of the material. The precise light frequency for the creation of such excitons and the speed at which they move depend on both the properties of the material and on the interaction with the electrons in the material. With a Wigner crystal, for instance, showing here the image, a schematic of quantum phase transition from an electron liquid to a bilayer Wigner crystal. Each ball represents a single electron. So that kind of shows you how the electrons melting or going through a phase transition from electrons into the organization of an ordered structure of a solid structure of Wigner crystals. So solid state electron. Crazy. And water does that same thing through phase transitions, and charge separation does the same thing as any phase transition goes through these layers. Hierarchical, lowerarchical, super cool. The periodic arrangement of the and that was cited back there. This is I cite this article here. The periodic arrangement of the electrons in the crystal gives rise to an effect that can sometimes be seen on television. When the bicycle or a car drives faster and faster above a certain velocity, the wheels appear to stand still and then turn in the opposite direction. This is because the camera takes a snapshot of the wheel every 40 milliseconds. If In that time, the regularly spaced spokes of the wheel have moved by the exact distance between the spokes. The wheel seems not to turn anymore. Similarly, in the presence of a Wigner crystal, moving excitons appear stationary provided they are moving at a certain velocity determined by the separation of the electrons in the crystal lattice, resulting in the patterns that I saw in the Dougherty set and the patterns that we're seeing that they took photos of for the first time, proving Wigner crystals exist. The first direct observation, a group of theoretical physicists led by Eugene Delmer of Harvard University, who is moving to the ETH this year, had calculated theoretically how that effect should show up in the observed excitons frequencies of the excitons. Excitation frequencies of the excitons. And that exactly what we observed in the lab, Muglio says, in contrast to previous experiments based on planar semiconductors in which Wigner crystals were observed indirectly through current measurement. This is a direct confirmation of the regular arrangement of the electrons in the crystal. In the future, with this new method, Muglio and his colleagues hope to investigate exactly how Wigner crystals form out of a disordered liquid of electrons. Liquid, quote unquote. Interesting. Okay. Here's the reference. Signatures of Wigner crystals of electrons in a monolayer semiconductor. And here is the reference to the article, and here's the people who wrote it. So I wanted to show this undoped system here. Liquid electron state, Wigner crystal electron state, closed. So exciton clap scattering off the Wigner crystal. What is Wigner glass? Low density insulating state is the Wigner glass, a phase with quasi-long range translational order in competing ferromagnetic and antiferromagnetic spin exchange interactions. The transition is the melting of the Wigner glass disorder between the agent, allowing the transition to be the second order, which is right here. Now I throw in the fine structure constant because that's coming out here. And in physics, the fine structure constant, also known as Sommerfield's constant, commonly denoted by A, the Greek letter alpha, is a fundamental physical constant which quantifies the strength of the electromagnetic interaction between elementary charged particles. What is the meaning of 1 over 137, fine structure constant? Its periodic value is palindromic and has a period length of only 8.1 over 137, was once believed to be the exact value of the fine structure constant. Interesting. Didn't know it had some palindromics. Cool. Okay. 3D and 4D Wigner crystals. Taking the idea and concept of Wigner crystals from one-dimensional strings and two-dimensional sheets, we start to veer towards the galactic circuits of birkeland currents. Wigner crystals in the Dougherty set. This pattern is a clear representation of what is happening in the atomic nucleus. Not only is this pattern happening on a nuclear scale, but it is also occurring on cosmic scales. In the filaments of birkeland currents, the simple discovery has so much potential, it hasn't even been noticed or begun to be tapped yet. Reality is layers of crystallized electrons. So if you go back to this, you can see that these are stacked layers, and it goes outward, and it also goes inward. And these are outer layer electrons are always on the outside of the atomic structure. So these would be like different shells around. This would be always on the first fundamental outside, and all the inside stuff is the atomic structure. So this is once again showing the outside orbitals, cascading orbitals and suborbitals of the electron.
All right, guys. Unfortunately, we got interrupted, and we're going to have to move right on to the news hour. So I think that was pretty much close towards the end of the presentation. I was going to show part of our World Expo, our Electromagnetic 2022 World Expo in Detroit. But here we go, on to the news hour.
All right, welcome back everybody to the geometric view. We got cut off a little bit early there on that. I was just calling everybody, doing a call out for a call for vendors, artists, a bunch of different things, electropyrographers, people who build plasma lamps, experimentalists, people who sell games, all sorts of different things. We're having vendors. We have an open bar from 12 hours. This is all from the for the event that we're having, the Electromagnetic Universe event in Detroit. We got a lot of speakers already coming. The slots are filling up quick, so it's a call for speakers as well. We got dancers, musicians. It's going to be a great time. It's going to be an expo, World Expo. So let me share my screen here. Desktop, start sharing. All right. Now, I'm going to get into the news hour. So thank you everybody for being here for the episode about Wigner crystals. That was definitely a lot of technical terms, but I hope I explained it in terminology that allows us to understand that there's layers of electron crystals, I think, that we're inside of, and even on the smaller scale, larger scale, could be the phase transition between the ether and the different boundary conditions, drums. Okay, so now we're going to go into the news hour, so I'm going to get into Facebook. The Geometric View News on Facebook. That is our channel. If you want to check it out. This is the first time I've done news in like a year. So there's going to be so much news. So it's going to be actually like the news hour this time. An entire hour. Look up here. Geometric View News. There we go. Yeah, there's 342 members, and I didn't approve anybody. This was just supposed to be like for me to reference for the show, but a lot of people like to be here, so thank you for all the people that are here. I mean, in Electric Universe Geometry page, we have 36,000 people. So I mean, I got a bunch of different pages with a lot of people who are into this this privy information, and it's not entitled. It's very intuitive. It's very understanding, very easily understood. So yeah, episode 58 here. Hopping into the news hour. Check it. What do we got here from my buddy Jane 108? Wonderful gentleman. Haven't met him before, but I just love his content and his energy. Beautiful imagery here. The structure of the universe and light refracted on water. Let's see if it gets bigger here yet. I don't know what that is. Here is Another model from George Leoniak, who we interviewed a couple of episodes back. I can't wait to have him on for another episode here. Just lovely work, incredibly beautifully orchestrated. You can see the phase conjugation, the collapse, the implosion, the explosion, the resulting star geometry. Yeah, there's just so much going on. Beautiful. Great work again. This is a fun one just to watch. Just to look at. I don't know if there's... Let's see if there's sound with this. No sound. Just great to look at. Frequency and waves. What's the title of that one? Really cool to see the lysigeous wave patterns on these. Speaking of electron orbits, orbitals. Alright, we got... Oh, this one's cool. Boom! Building up charge inside that equilateral triangle. Seeing things like the outside images, the outside patterns of things, like Jason Piaget, a friend of mine here on Facebook, who has sudden savant syndrome. I haven't been tested for it yet, but I had a really bad injury, and then after that injury, I saw everything different, and my artwork changed, and I got into more geometric drawing. So it changed me as a person. I had an out-of-person OBE, out-of-body experience. Saw a bunch of people that weren't there. But yeah, there's only 23 of confirmed cases of sudden savant syndrome, so I wouldn't be surprised if I might be... there's only 22 or 32, so I wouldn't be surprised if I'd be the 33rd discovered person with sudden savant syndrome. After all, one of my best friends says that I'm the most fully functioning idiot savant he knows, and I think the cat's out of the bag. I definitely probably am on the Asperger's spectrum, but I've never used that to my advantage or disadvantage in life. But I think it would help a lot of people understand who I am and why I operate the way I do. I'm weird. I just ain't normal. I'm different. That boy different. That's me. Here's toroidal acoustics. Beautiful image here. Just gorgeous image of toroidal acoustics. You can hear them. You can hear the corkscrew of that sound of that. It's like a Whistler wave, like helicon physics, like. Or, yeah, some cool noises for sure. I can see. Don't know if I can make them and correlate it, but. Beautiful. Speaking of toroidal acoustics, here's some more, another image. Spiral metasurface reminds me of a sphincter, an opening and closing sphincter. Reminds me also of another buddy who, another friend who is on the podcast here, David Schiermeyer, who does the bubble cymatics, the sound and the divots, and that also reminds me of the wells and the perturbations and the voids that we were talking about with the Wigner crystals and the structure and the larger structure of it and substructure. But this is really cool. Focused and unfocused, and the sound, how it comes in and moves out. And here's the lenses down here. Good stuff. This is just freaking strange. Apparently, let's hear the story here. Workers removed the asphalt in Russia and found this mysterious road made of metal. You know what, they have always had some fancy explanation to shape your perception of how primitive we were. Good old days. Sarcasm aside, riding a horse with carts would definitely be a nightmare on this road, and not to mention walking. Many of us know exactly what this was made for. These metal rods were used for to delegate the electricity and ground negative potential, and the dome towers used as antenna receivers. Same thing was applied in ancient tombs, aka churches, mosques, temples that all have copper floors. For those that are new to this research, Tartaria. That's from Tartaria Mud Flood Group. Reminds me of this, and the dome of the Rock, dome of Israel, dome on top of all the cathedrals. More of that type of acoustics and what have you. Grid powering lattices of structures and whatnot. The inverse square braid of consciousness fundamentally inherent within the Dougherty set. Beautifully splayed out before you here, and also how it has to do with the magnetic wavelet and the layers of the braid. Beautiful filamentary network, showing off a lot and how it goes from one layer. Actually, let's look at it again. How it goes from this outer layer, right, to this next layer. Okay, and then you dial into the next dilation, and it shows the two centered by the center. You go to the next toroid, and each one of them are petals that are existent inside of the toroidal structure there, inside of the emergent magnetohydrodynamic geometry. This is really cool. We should probably just sit and watch this. I don't want to get a copyright strike on the music there. So we'll just take a minute and watch this beautiful vector geometry of the planet orbitals. This is one of my favorite ever in the world, because I designed a model. I hope we get to see it here in the images here. That's the breathing of the it's a helical toroidal Minkowski breathing space-time metric. How many other words do you want to use for it? I've built a model that's like this, and there's a bunch of smaller scales, and I found out that this happened because I threaded it with 12 threads, and I found out that the lens of the pinching point of a Z pinch, a Z pinch, is the center point of where those two line up. So that could be thought of as a Z pinch as well. And in the Dougherty set it is, and there's subsequent Z pinches and smaller perturbations which make up the different layers, which Elon Musk would say orders of magnitude, a couple of orders of magnitude within, beneath, or under, above, you know. So what we have here is from Benjamin Hyde, another electric experimentalist. The power to move. Can electricity move mountains? Absolutely. 9 kilovolts of AC and 0.06 amps. Some beautiful footage here by Zerg Labs. Unfortunately, they're in Russia, so I invited them to come and bring their plasma swords and plasma lamps and sell them. And these are all wireless. You know, they're all run on Tesla coils. So the sounds of these are just amazing. Let me see if I can put the sound on this. That sound is just here. Let's see if we can hear this. Dude. Whatever. It's not playing the video now. It's being a jerk. There it is. Can't hear. Anyway. Okay. So yeah, he can't make it, but yeah, this is what I mean by a call for plasma artists, trying to find some local plasma tube artists, get jewelry makers, whatever they're doing, to come to the event. So astronomers discover a space structure of unknown origin larger than the Milky Way. This is what I'm talking about as larger outer structures. Like this whole wall could be a formation of Wigner crystals, crystallized. Like it could be absolute zero at this wall, at this threshold, and that's where the Wigner crystals exist and reside, holding the larger galactic intelligence of the subsequent smaller structure. And then there's, you know, heliopause, heliospheres, magnetospheres, bubbles. You know, there's an interface there, and what's happening is the geometry of phase transitions taking place, and charge and charge separation. So, what is this structure? Let's see what this is. While that pulls up, I'll continue going here. Dale Pond here sent this to vibratory physics, sympathetic vibratory physics. Keely's cosmic energy source, Whistler waves and electron rain, the low altitude electron rain measurements by E. Alphin, combined with the Themis observations of Whistler waves in space and sophisticated computer modeling, allowed the team to understand in detail the process by which the waves cause rapid torrents of electrons to flow in the atmosphere. Sweet. That's exactly what we're always talking about here. Super fast electron rain. Cool. We're going to have to get into that article. Let's check this one out first. Astronomers discover a space structure of unknown origin larger than the Milky Way galaxy itself. A team of astronomers has developed new details of one of the strangest cosmic structures in the universe. So strange that they are literally referred to as odd radio circles. ORC, orc? Weird. This is my first time reading all these articles, so that I don't mind me if I get too into it. Odd radio circles. What? Orcs. Kind of what I'm talking about, guys. These colossal phenomena and ooh, orcs, dude, it is what? The Wigner crystals are made of just nothing but circles. Like this could be odd radial circles. These colossal phenomena may have diameters of 1,000,000 light years, nearly 10 times larger than our galaxy, and are still unexplained. Orcs are so rare that only 5 of them have been discovered, with 6 more candidates not yet confirmed. So, yeah, but the same was with black holes and Z-pinches. Now everything's a black hole. There's multi-scale black holes, but we call those Z-pinches and other formations as well here, according to the electric universe cosmology. Scientists simply do not know what they are and cannot explain these beasts of proportions incomprehensible to humans. A new scientific study published on March 20th sheds new details on the first of these phenomena. The spectacular images, which you can see in the article, were captured by the South African Meerkat radio telescope and correspond to the object known as Orc 1. Never before has an orc been seen in this incredible level of detail. The work offers so much detail that the journal Nature points out the radio astronomer of the National Autonomous University of Mexico, Alice Paceto, affirms that the discovery will initiate new scientific investigations among astronomers. Here's the unsolved mystery. According to radio astronomers Korbelaski of the Australian Commonwealth Scientific and Industrial Research Organisation in Sydney, it is reminiscent of a Fabergé egg or soap bubble. The outer circle, dude, it looks kind of like a rouleau shape, a rouleau solid, dude, like I was talking about. The outer circle measures more than 1,000,000 light years in diameter, 10 times the diameter of the Milky Way, with a series of smaller rings inside it. Boom, boom, boom. Dude. The Orc cloud. Wow. Orc cloud is like Oort cloud, and I'm going to show the similarities here in another video. I'm already putting stuff together. Wow, in my head right now. Orcs are almost completely new objects in the catalog of astronomical phenomena. They were discovered by astronomer Anna Kapinsaka using the network of 1 square kilometer radio telescopes in Australia. Just 3 years ago, scientists were so surprised that initially it was even thought that they could be instrument collaboration errors. It is now known that they are real structures, although we still do not know how they could have been produced. We don't know exactly what these edge-brightening circles are or how they could occur. We know that they can be seen exclusively in the radio wave spectrum, not in the visible infrared or X-ray light spectrum, and that 3 out of 5 have a center that coincides with the center of a visible galaxy. Oh boy! That is sweet. Centrality. All coming out of the center. It's all hollow. The universe keeps calling us. According to this new study, there are now 3 possible explanations. The first, that is, it is the remnants of an unimaginably large explosion at the center of galaxies. This explosion could be the collision of 2 supermassive black holes, although we can only speculate about its possible origin. The second possible explanation could be the shock wave resulting from the birth of millions of stars. And a third could be jets that spit out highly energetic particles into the center of galaxies. Wow. Those are all fun and interesting to think about. But in the end, astronomers admit they can't explain why they are so rare, as Western Sydney University professor Ray Norris, one of the study's co-authors, points out. We know that orcs are rings of faint emissions that surround a galaxy with a very attractive black hole at its center, but we don't know yet what causes them or why they are so rare. Orc 1 measurements published in the study. It is truly amazing that we have only been able to detect these strange and mysterious structures in the last 3 years. They have obviously been around for eons. Astronomers think they formed over 1 billion years, but the fact that we're still discovering things at this point just goes to show how much we still have to do. In the end, the only thing we know for sure is what Socrates said: we know nothing. The universe keeps moving us, that it is full. Oh, we know nothing. The universe keeps reminding us that it is full of unsolved mysteries. Research to discover the secrets of the cosmos and therefore the origin of the human being must continue and increase in the coming years. It is the great adventure that continues to drive our desire for exploration, our very existence as a species, and the fundamental engine of our civilization. Without it, we will have no future. No future. So that's that article. Let's open this one. This looks cool. Always what we're kind of talking about here. We'll wait till that opens up and look at the next one. Coming up here, NASA reveals that once every 8 minutes, mysterious portals connect our planet with the sun. I'd say it's more perpetual, but there's probably an opening and a closing of the perturbations. But yeah, that looks interesting too. Let's see what this other article here is. Superfast electron rain. UCLA scientists have discovered a new source of superfast electronic electrons raining down on Earth, a phenomena that contributes to the colorful aurora borealis, but also poses hazards to satellites, spacecraft, and astronauts. The researchers observed unexpected rapid electron precipitation from low Earth orbit using the ALPHA mission, a pair of tiny satellites built and operated on the UCLA campus by undergraduate and graduate students, guided by small teams of staff mentors. By combining the ALPHA data with more distant observations from NASA Themis spacecraft, the scientists determined that the sudden downpour was caused by Whistler waves, a type of electromagnetic wave that ripples through plasma in space and affects electrons in the Earth's magnetosphere, causing them to spill over into the atmosphere. Their findings, published March 25th in the journal Nature Communications, demonstrate that Whistler waves are responsible for far more electron rain than current theories and space weather models predict. ALPHA is the first satellite to measure 3 superfast electrons, said lead author and researcher in UCLA's Experiment of Earth. Planetary and space sciences. The mission is yielding new insights due to its unique vantage point in the chain of events that produces them. Central to that chain of events is the near-Earth space environment, which is filled with charged particles orbiting in giant rings around the planet, called the Van Allen radiation belts. Electrons in these belts travel in slinky-like spirals that literally bounce between the Earth's north and south poles. Under certain conditions, Whistler waves are generated within the radiation belts, energizing the speed-up of electrons. This effectively stretches out the electrons' travel path so much that they fall out of the belts and precipitate into the atmosphere, creating electron rain. Wow. One can imagine the Van Allen belts as large reservoirs filled with water, or whoops, did they just spill the beans? Filled with water, or in this case electrons, that Vasilis, UCLA professor of space physics and ALPHA's principal investigator, as the reservoir fills, Water periodically spirals down into the relief drain to keep the basin from overflowing, but when large waves occur in the reservoir, the sloshing water spills over the edge, faster in the greater volume than the relief drainage. Alphen, which is downstream of both flows, is able to properly measure the contributions from each. The low-altitude electron rain measurements by Alphen, combined with the Themis observations of Whistler waves in the space and sophisticated computer modeling, allowed the team to understand in detail the process by which the waves caused rapid torrents of electrons to flow into the atmosphere. The findings are particularly important because the current theories and space weather models, according for which other sources of electrons entering the atmosphere, do not predict this extra Whistler wave-induced electron flow, which can affect Earth's atmospheric chemistry, pose risks of spacecraft, and damage low-orbiting satellites. The researchers further showed that in this type of radiation belt, electron loss to the lower atmosphere can increase significantly during geomagnetic storms, disturbances caused by enhanced solar activity that can cause near-Earth space and Earth magnetic environment. Although space is commonly thought to be separate from our upper atmosphere, the two are inextricably linked. Angiopoulos said, "Understanding how they are linked can benefit satellites and astronauts passing through the region, which are increasingly important for commerce, telecommunications, and space tourism." Since its inception in 2013, more than 300 UCLA students have worked on Alphen, which finally they give the acronym for Electron Losses and Fields Investigation, Alphen, which is funded by NASA and the National Space Foundation. Blah, 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 blah. Okay, so yeah, that's more information about helicon physics and Whistler waves, stuff that we talk about constantly on this show. So that's cool to know. Let's see what this every 8 minutes thing is about. All that upload, we'll see another awesome video. Chris Barak, he's a Canadian, trying to get him to come, or him and or his wife's work featured in the 2022 Electromagnetic World Expo in Detroit. The event we're hosting. It looks like that article's still opening. In the meanwhile, let's check this one out. These are just gorgeous. Let's open this full. See if I can open this full size. I don't know why it's not allowing it. There we go. Okay, so think of perturbations in Birkeland currents. Look at that. That same type of breathing with the parabolas. In-breath, out-breath, toroidal sequencing. Just the same geometry as rolling around the hub of a wheel. It's all gyroscopic. Beautiful. Yeah, this another beautiful geometry. Skyrmions, skyrmionic magnetic topology geometry. Another episode that I'm going to be putting on. Mike Ferreira here, another post of his showing the skyrmionic bundles, magnetic skyrmion bundles with different plateaus and Mono Lake here in cave shelves, showing the similarities on how they build the structure. It's all electromagnetic. Another beautiful one here, showing the electromagnetic aurora borealis and agate, a beautiful stone, showing that multi-layered, multi-nested, dual layer, indicative of plasma, counter rotation. Don Scott's always talking about. Another beautiful one here by Namara Araman. It's just great looking at that, the substructure of the nested conics coming down, and the base of the birkeland current being a multi-nested blue whirl, geometry of the blue whirl. It's how they dock. It's how a birkeland current docks into spheres and builds atmospheres. Multi-nested docking. It's efficient charge distribution across the layers. This is what I was talking about with Elon Musk, and just a couple of orders of magnitude. Here's one order of magnitude. Is 2 orders of magnitude. A couple of orders of magnitude right here, right there, and here, and there. Few orders of magnitude higher, lower. You could also, people can say that's dimensions, like this is dimension. You kind of get lost when you start talking about that, like it's 11 dimensions and all this other stuff, and it's like, no, you can break it down simpler than that. So, anyway, here we go. What does NASA reveal every 8 minutes? During the time you are reading this article, something will happen high above your head, which many scientists did not believe until recently. According to NASA science, a magnetic gateway will open between the Earth and the Sun at a distance of 150 million kilometers. Opening and closing, breathing, just like we were showing before. Oh man, that conic, pinecone kissing noses type of geometry is all up in that right there. This space will be filled with thousands of high-energy particles until it closes about the time you reach the bottom of the page. It is known as Flux Transfer Event, FTE. According to NASA Goddard Space Flight Center's space physicist David Seebeck in 1998, I was convinced that they didn't exist. But evidence now shows me incorrect. Indeed, David Seebeck proved their existence in 2008, and he presented his results during a plasma lecture at an international meeting of space physicists in Huntsville, Alabama. The Sun-Earth portals occur every 8 minutes, according to NASA. Scientists believe the Earth and the Sun have been linked for a long time. The solar wind carries high-energy particles from the Sun into the magnetosphere, the magnetic bubbles that surrounds our planet. Magnetosphere, magnetic bubble, like I was talking about, breaking the Earth's magnetic shielding. We used to think this relationship was permanent and that the solar wind might permeate near Earth space anytime it was active. Seebeck continues. There's a little video. Sorry about me talking in the background there, everyone. Escape the full screen here. I'm trying to escape the full screen. There we go. All right, well, that was really interesting. That is super cool. Wow. Let's see. Let's open up this one. This one looks really good. I know I saw it. I saw a lot of these articles, and I never had time to read them. I saw a lot of these articles, and I never had time to read them. So I just posted them here, and I'm excited to read them all with everybody else. Mysterious vortex waves discovered on the Sun hint at new solar physics. Uh, Reminds me of how alternating current was discovered by Nikola Tesla by looking at the sun and seeing the magenta and the cyan moving in counter-rotating, counterclockwise, or counter-rotating directions. You can see it on the sun if you just look at it. At night, you can see the circles that dance around the outside. So let's see what this article has to say about it. The new type of high-frequency acoustic wave discovered propagating on the sun's acoustic wave. The waves appear on the surface, sonobiology. The waves appear on the surface of the sun. I'm going to wait, saying that something's unresponsive. So hopefully everything's still up and running. Yeah, I believe Skype's up and running. We're still recording. All right. The waves appear on the surface of the sun as a pattern of swirling vortices, moving against the sun's rotation, counter-rotation. The problem is that these high-frequency retrograde velocity waves seem to be moving 3 times faster than predicted by theory, and solar physicists have been unable to determine why. Man, my computer's really mashing up here. Looks like the whole system's breaking down. Might have to rendezvous. Put the rest of this on the next news hour. Let me go to Skype here, see if that's even opening. Yeah. Still recording. I'm good. Okay, let's see if we can continue. Close that. All right, here we go. Yeah, we're continuing. Throughout the group, let's see. Oh, this is just beautiful geometry here of nested icosahedrons inside of icosahedrons. Beautiful. That is just super simple, showing the circle, just a simple line moving with an arm creates a helical path when you add time to it. Episode of George Leoniak and I. Walter Russell. And researchers create holographic plasma lens. I think I already got into this. I think I started getting into some of the news hour on couple of the last podcasts. This is an old painting that I made. Let's see, probably around 2008, 2009. Yeah, around then. Yeah, took a few years, as most of my batiks do. I'll have them around and work on them for a while and see exactly what I want to do to them. But it is batik painting, B-A-T-I-K. Close that out. And I just remembered I did get into some of this geometric news. There's an image from, it looks like it says Pascal Schulben, or something like that. Really kind of reminds me of the Dougherty set, and I'm going to do an image that's very similar to this, and, like, also other people's posts were like, reminds me of rectal examinations from these alien visitors. How to make a sound wave spin. Yep, hit a pipe. Yep, I remember doing this stuff on one of the other news hours, so maybe we can catch up, and I'm sure there's so much more. I mean, I could go on for a long time in this news hour. I eventually gotta go back through some of the stuff I posted last year, so maybe we'll hit that in the next episode. Well, thank you everybody for being here on the Geometric View, episode 58, season 5. We will catch you on the next round. I did want to go into one more other thing and show Grandma's Space Kitchen, which is my newest company. Freeze-dried astronaut ice cream, and man, is it delicious. Grandma's Space Kitchen. Let's look at some photos here. Of course, it's not allowing me to show. One of the easiest things I can show. Start scrolling through all this. This is the freeze-dried astronaut ice cream. You can contact me directly on Facebook, DM, if you want some. Astronaut ice cream. I make over 60 flavors. It's a #1 club hit. We always have new products and new inventions. It's all and new discoveries, just like with the Dougherty set. I'm working with a lot of different people trying to create just different products. Here's a candy bar, my own candy bar. Look at the geometry on that. Of course, it's the Dougherty set. Plasma pinches, showing how galaxies form along filaments. Larger structures, smaller structures. They just don't believe. A lot of the modern day cosmologists are baffled when it comes to the geometry of these orcs and these Oort clouds, and these Hall clouds, which are these toroids. I just can't wait to get into that episode. I'm going to pick that one apart pretty hard. It's going to be one of my upcoming episodes this year, the Oort cloud and orc clouds. Probably do those simultaneously. But yeah, here's me at the toy show. It's super fun product. Everybody loves it. I do events, I do catering, I do birthday parties, weddings, funerals. I'm trying to do my first Irish wake this year. Cheer people up with some ice cream as we celebrate their passed away friend, family member. Bowling, zodiac parties. Yeah, it's pretty much this ice cream is. I have it. This was for St. Patrick's Day. It's ice cream that you can have anywhere, anytime. It's dry. You can eat it like candy in a bag, and it's freaking amazing. It's spectacular. I have all these flavors available. 25-year shelf life on this ice cream. I created these drinks. This drink that uses, hopefully not letting me out of that, but it's dry ice, freeze-dried ice cream, and your soda of choice. You put a bag of freeze-dried ice cream in it, and dude, it's popping, it's slapping, it's ready to go. Yep, freeze-dried astronaut ice cream. Good stuff, good times, good eating. There's our little logo. We were a sponsor at Bud's Bowling, something here in Michigan that's awesome. There's some club hits of lots of people at a really cool event. There's a bunch of events that I constantly go to. Freeze-dried food band, freeze-dried food restaurant, catering. Yeah, that's me. Grandma's Space Kitchen, baby. 25-year shelf life. All right, so thanks again for being here, everyone, and putting up with the news hour and my voice. We really appreciate the reason why we're here is because of your donations. I couldn't do this otherwise. Trying to do this full time. I mean, I paint. I do a lot of other stuff. I do house painting and interior, exterior. But I'm trying to transition fully out of that this year and do this freeze-dried astronaut ice cream and fully do this podcast and stay dedicated to all my viewers and work with the Electric Universe Geology, Electric Universe Paradigm, Thunderbolts Project, Ben Davidson, anybody honestly who's out there pushing the plasma universe. Dr. Anthony Peratt, just I could throw some more name dropping out there, and thanks for everybody and their help. Jim Wenninger, Neil Thompson, Ramon Correga. But yeah, thank you everybody for helping out. This is the new paradigm of the electric universe. Check us out online at the Geometric View. Check us out on YouTube, the Geometric View. On Facebook, Electric Universe Geometry. We have like 36,000 members. Come and join and converse and share, learn with us as we teach and learn together. Thank you again. Have a good weekend, and we'll see you next week. Bye.
The Geometric View is a Love is Watching product. Love is Watching being. Thank you for doing that. Keep your eyeballs out. Pay attention. There's a lot going down this year. Be vigilant. Be mindful. Be insightful. Be loving. Thank you for being here. Thank you for being kind. Share the love. Spread the love. Become the love. Amen.
cause. Love, life, live it to the fullest. Life is eternal, hope and thirsty. 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 Life is eternal, hope and thirsty.
As I look at the wall, as I look at your body, can I just see straight through with transparent golden scaling? The largest of the atom, let's embark on this because this is the journey. The journey is life. Take hold. Here we go. 3, 2, 1.
Shout loud for the glories of God. Shout loud.
at how showers land.
Shout out for the glories of God. Shout out. Shout out for the glories of God. Shout out. Shout out for the glories of God. Shout out. Shout out for the glories of God. Shout out. Join us in the fight for Christ, in the fight to save lives. Surprise, submersible, so fast, the first, the last of baptism. Need to say more. Pay attention like the marrow in your bones, zero in your back, arrow in your lungs, zero into the back, tertiary Christian neuron synapses, and narrow entrance into eternity. I'm a courier, a charismatic attitude, modern meters even meter, it might even be fun. Cider indeed, need nerds, you need nerds, need a virtue, need to be a reason. Feasibility to be a reason to be clean and sober, keys, open doors, signs of directions. Be the carrier of candlesticks, the man to brought you change. Every second you ride, until make the ribbon, you pivot, but touching your curving cat. Could be cold, could be copycat, could be copy corpse, could be Schrodinger's best. Could be micro actor, Mackie normal, open-minded, itsy bitsy, freaking huge, a universal supermassive aspect of attached awareness. Aware of this all? Collaborative consumption. Are you aware of this all? Collaborative consumption. The new thing consumption. Collaborative consumption. Consumption. Get up now! Out of the boat! Drop! Where did this up? We don't got about a girl, but about a not about a goddess spirit. Get up, what's up? Get out, tap comes. We're playing on the little foot up. I'm in search of, I'm in earth love, I'm in living life, I'm in living color, I'm an air drop, I'm an earth thing, I'm an earth thing, I'm an earth thing, I'm an earth thing.